Today we're going to talk about inverse function. We're going to go to our note sheet and then you'll have a practice sheet to do. So for inverse functions, I like to let people know to just always think of anything that says like g of x or f of x as a y. So we're just going to change all of these to y. It really makes it easier when we go to do these sort of problems. Yeah, all of them. I know it's a lot. So we're changing them all to y, even the ones on the bottom. So when you do inverse functions, the first step is to switch the y and the x, and only the y and the x. Everything else stays the same. So it's going to become x equals 5y plus 15. So you switch the y and the x. And then the second step is you solve for the y. So there's only really two steps. So once I switch my letters, I want to get my y value by itself. So I want to get rid of the thing that's furthest away from y, but on the same side with y, which is my 15. So I'm going to subtract it. And I know that these two cannot be combined. So I'm just going to write them side by side. X minus 15, I'm going to write it out horizontally, equal to 5y. And I like to put a little box around my y just so that way I know I'm trying to get y by itself. So you'll see that this 5 is touching the y, and that indicates that it's multiplication. So we're going to think of what's the opposite of multiplication, which is division, to get y by itself. And then we'll come over here and we'll divide both of these by 5. So you can go ahead and leave your answer over 5 on this side. So this would be fine. Some people prefer to split it up so we can make it x over 5 or 1/5 x, and then 15 divided by 5 is 3. I'll accept either of these answers, but just know if you are taking like a placement test for Ivy Tech, or you're in another math class kind of working ahead, your teacher might like you to have it written this way. So once we have the y by itself, we know that we are good to go and we have our problem solved. So here we're going to go ahead and switch our x and our y. Just like so. And then our mission here is to get the y by itself. So for this one, there's that lonely 3 in the bottom. So we're going to get rid of that 3 first. So since it's division, we have to multiply by 3 to cancel. And what we do on one side, we have to do to the other. So we'll have a 3x equals a negative 2y minus 6. If you want to get y by itself, you can put that box around you to kind of, or your box around your y to kind of help you do that. The negative 6 is a little further away from the y, so we're going to add that over. So we know that these two are not like terms, so we have to keep them separate. 3x plus 6. Kind of had to shift my problem because I ran out of room. Equals negative 2y. And then we're dividing by negative 2. So you can either divide this whole thing by negative 2 and leave it, or you can split it down and make it a 3/2 negative with an x, and then 6 divided by negative 2 is negative 3. So I would take either of these as a final answer for your problem, whether you split it up or you leave it all over it. But I do kind of think this looks a little bit nicer. So we'll go to this one over here with an exponent. So if we're trying to start our problem, we're going to first switch our X and our Y. We always do that first. So when we're doing this, we'll try to isolate Y or get it by itself. So we're going to start with adding our 3 over since it's the furthest away from the variable. And this is where sometimes people get a little bit mixed up. Since we have an exponent, the opposite of an exponent is a radical. So you may have seen this before in quad formula. It's this little check mark thing. But you have to put whatever number inside that you see out here. And that will cancel with your exponent. So then you'll have to also do that over on the left side. That leaves us with just a y plus 2. So we'll have to move our 2 over by making it a negative. So we'll drop this down. Now, since that 2 is being moved over after we took the root, that minus 2 has to stay on the outside of the radical. So this would be your final answer there. So the key thing to know is that exponents and radicals are opposites from each other. So we'll try another one with the exponent. We'll switch our X and our Y to start. And then we're trying to get Y by itself. So we'll go ahead and move our 3 over first, which is X minus 3. Then we have our 2Y to the 5th. So when we're trying to get Y to the 5th by itself, we have to get rid of the 2 first. The way I explain this to people is it's the opposite of PEMDAS. So usually exponents go before multiplication and division, but when you're doing inverse functions, multiplication and division go first. So we're going to divide by 2, divide by 2. And then since we have this to the 5th power, we have to do the opposite on the other side to get rid of it. So what's the opposite of an exponent of 5? A root of 5. But you have all of this stuff. So how are you going to draw a square root over all of that? You're going to have to draw a pretty big square root sign and then put your little 5 in there in order to get rid of that. And you can show it on both sides so that way you know that they cancel each other out. So our final answer could just be circled there, but it's a little on the messy side. So I'm going to rewrite it over here. Like so. So as long as Y is by itself, you're good to go. So some of them have radicals to start, and you're going to be doing the opposite, which is exponent. So for this one here, after you switch your X and your Y, you can get rid of that number that's kind of an outsider to the radical first. So we're going to add that over. So that gets us X plus 2. And then from here, you have this radical 3. So if you want to get rid of that, you have to think what's the opposite of a radical, which is an exponent of 3. So what you do on one side, you have to do on the other. So you'll raise that side to the 3rd power, which leaves us with this lonely little 1. And since it's a minus 1, when we bring it over, we'll make it a plus 1. And then our Y is by itself. So those ones are a little bit easier, at least in my opinion. The last one we'll do is this one here. And then the bottom is just deciding what the inverse is of the first equation and seeing if it matches the bottom. So we can try one of those. Since you have a root of 3 and everything's underneath of it, you want to start with your exponent to cancel that out. I kind of forgot to switch my letters to start, so let's actually start there. So we had our root 3, and if we want to get rid of it, we raise it to the third. So we'll also have to raise this x to the third. So it looks something like this. All of this stuff is on the top, and this division by 2 is in the bottom. So we got to think what's the opposite of division, which is multiplication, just like so. And then we have that little 3 at the end. If we want that to come over here and it's a negative, we have to add it over. So it'll be 2x3 plus 3 equals y. For the very, very, very bottom ones, they're the same thing that we've been doing. You'll essentially find the inverse of this and see if it matches this one down here. So you'll switch your x and your y. Maybe you take the top one. And then you'll ask yourself, how do I get y by itself? So if I have a 5th root, let's take this to the 5th power. And then I'm left with this expression. If I want to get the top by itself, I need to multiply by 2 since I have division by 2. Whatever I do to one side, I do to the other. You can't really see that. Yeah, I had division by 2, so I multiplied by 2. And then I want to get rid of my 3. So since it's a plus 3, I'm going to minus it over to the other side. And this is almost 100% done. Now, since it's a negative y and we want it to be a positive y, we can divide them all by -1, or we can just switch the signs. Either way is going to get you the same answer. So you have to look at this equation and ask yourself if it's the same as this bottom equation. So they both have a negative 2x5. And this one has a negative 3, and this one has a positive 3. So if this equation right here does not match this one perfectly, then it is not inverses. So we just put no. And we did all that work just to get a no. But if that had a positive 3, we would put yes. But since it's oh, you know what? Miss Amanda messed up. A negative divided by a negative is a positive. So the answer is yes, because we have this expression matching this expression. So they are inverses.